Chapter 3 is about data visualization. This is a very important part of any sort of statistical analysis you might possibly do, especially data mining. And for that reason, this is covered early in the textbook, and you'll find that in the software we're using, JMP, there are quite a few very useful tools and resources that help us to be able to understand any of the variables and a lot of the relationships between the variables. And doing this in the pre-processing stage is very useful in helping us determine what exactly it is we're trying to understand and what information we can extract from the data. The JMP software is, as I said, very useful, and but let me say that there are other software packages out there that are dedicated solely to visualization, things like Tableau, Spotfire, and several others that really lend themselves to quick and easy examination of large data sets. And we're not going to get into those because the learning curve is actually quite steep on those. What we do in JMP should be fairly straightforward, and you'll see as we go through this some of the pictures and graphs that are generated using JMP. So what are the types of graphs that we have? We've got line graphs, bar charts, scatter plots, mosaic plots, which is just another way of combining bar charts together. And then we also have box plots and histograms, which would be considered under the distribution plots to help us see all of the data all at once. And other than the mosaic plot, you certainly have seen all of these things when you took your Stat 601 course or whatever introductory stat course you took. The mosaic plot maybe you haven't seen, but it, as you will see, is pretty straightforward. And the data that we're going to use in this chapter are the Boston housing data set and the ridership on Amtrak data sets, and both of those are available in JMP. When you're inside of JMP, you can open the graph builder, and when you do, this is done as you can see here for the Boston housing data set. You have a list of variables over here. We've got the 14 columns, and over here we have a place where you can drag and drop these things. So for our y variable, we could pick whichever one it is we want, put it here. For an x variable, drag it down here, put it in here. And if we want to look at what are the some of these basic charts that we talked about, we have the line graph, the scatter plot, bar chart, and the mosaic plot. And we'll talk in more detail about each of these. Starting with the line graph, and this is a time series data set. This is the Amtrak ridership in thousands. I think it's monthly. And you can see that there are peaks here, and this is kind of there's a cyclic relationship here, so peak, 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 and you can see those peaks, and we have troughs, and those peaks and troughs correspond to something, some time frame, some window of time when ridership is high or low. It looks like it's seasonal, and so in time series you would look for patterns like that. You would also look for trends. So there's a trend that goes like this, and then there's a pattern on top of that, and then on top of the pattern and the trend there is noise. And we're not really going to get into time series analysis in this course, but this is a typical graph that you could use for that. You could use line graphs for other data as well, but you want to be a little bit careful if you have an arbitrary ordering on the x-axis, then you can start reading things into your data that aren't really there. So you got to be a little bit careful about what you put on the x-axis if it's not a time series data set that you have. Here we've got a bar chart, and what we're looking at is the median price of a house in the Boston area. We've got it broken down according to whether the house is on the Charles River or not. So 0 means it's not, 1 means it is. And we can see that the median house price is lower for those not on the river than those that are on the river. So we get a real good, quick idea of how those houses might differ in different scenarios. Scatter plots are very useful. We will use these quite extensively, and this helps us to, or allows us to see what the relationship is between any two variables. So we have median house price on the left, and we've got LSTAT on the right, or on the x-axis, median value on the y-axis. We can see as LSAT goes higher, what happens to the median value? Well, there looks like a nonlinear relationship between these things. Distribution plots are very useful. These help us to see not just the data, but the shape of the data. And this can help us to understand very quickly if there's skewness in the data, if there's outliers, if there are what the basic shape of the data is. And so the first of these that we look at is what's called a histogram. This is basically a bar chart, but for continuous data, or it doesn't even have to be continuous, but for numeric data. And basically what we do is we put the data into a bin. We say how many do we have between 5 and 10, and we count those up, and it looks like there's whatever that number is over there, and so forth. So we can see that the point that happens most often is in here somewhere, and because we have this thing sticking up right here, what that tells us most likely is that we really don't have a bigger number of data points between 50 and 60, but really what we probably are looking at is a truncated histogram. In other words, there's lots of stuff way out here, and we're just saying this is really 50 plus, so those show up here. Anyway, these data points out here are going to pull the average value up here, and compared to the median, we will then have a bigger value, which means we have a skewed data point set, and we would say the mode shows right here. So we have the mean, median, and mode, and combine those things together, that tells us we have positive skewness. Box plots are another distribution chart that we have access to, and you can see here on the Charles River we have on the left median value, on the right, on the left where Charles is 0, we have the median value for houses not on the Charles River, and on the right we have median house price for those on the Charles River. And you can see that the data set is mostly made up of zeros, and that makes sense. If you have a river going through a neighborhood, there's only so many houses that can be along the banks of the river, and you have lots of houses that fill in the rest of the space around. So the box plot doesn't show us that. What we see, or how we've made that determination, was by looking at the actual data points. But we can see the box plot, which goes from the minimum to the maximum, with the median here, and the mean is somewhere in there as well, but it's not denoted in this picture. In fact, if we look at this next slide, we will see that this is the max, quote unquote. It's not really the max, because you can see there's a bunch of stuff out here. These are all considered to be outliers, and outliers are important to be able to identify. Sometimes they're erroneously, sometimes they're the things that you're looking for, and in this case we've got outliers above the max, so obviously this max is in quotes, and so think of it as the maximum of the non-outliers. So how do you define an outlier? You say Q3, which is this third quartile, plus 1.5 times the interquartile range, which is the distance between those jump, the average value is going to be specified with a diamond, as you see down here. And so you get the mean, median. You don't know what the mode is, but you can make comparisons between the mean and the median and see that if the mean's bigger, then you're going to have positive skew. If the mean's smaller, you'll have negative skew. Box plots are really good for making comparisons, and as you see here, we've got categorical median value. So we said anything bigger than, I think it's $30,000 is a 1, and anything less than that is a 0. And then you can look at different levels of NOx, LSTAT, PT ratio, and so forth. And this lets you see how these things differ, and you might think of some of the statistical tests you ran in Stat 601 for comparing the average values for these populations or these subpopulation. We're not going to really do that in this class, but you can see that it looks like the PT ratio is different for those smaller priced houses versus the higher priced houses. Heat maps, color maps, and cell plots. These are 3 additional tools that are very useful. And the idea here is that if you have a very large data set with lots of variables, for example, you could look at the correlation matrix, and when you do that, you're going to see there's lots of correlations, because if you have n variables, then you have n times n minus 1 over 2 correlations. So if you have n variables, then you have lots of correlations, and so this is on the order of n squared, and that's hard to look at a bunch of numbers. Correlations are always between -1 and 1, so you might look at them and say, well, they all kind of look the same. But with this heat map, you can look at it very quickly and see where the correlations are similar. So bright red is 1, blue is -1, so you can see the correlation structure of this data set very easily down here in the heat map. It's much easier to do that here than looking in the actual correlation matrix, although here they have it color coded as well. Missing data can also be described using the same sort of notion, and anywhere you've got red, that means there's no missing data. Blue means there are missing data points. So you can look at this and see very quickly, very easily where the data is missing, and it's all kind of color coordinated. And you can do basically the same thing with a tree map. And the way this works is, for every column, there's either a 0 or a 1 for each individual observation that says there's a missing or non-missing. So 0 means it's non-missing, 1 means it would be missing. So there's 277 observations or rows in this data set that have no missing data, and that's 51.39%. And each of these other rectangles represent different combinations of missing values. So this one, for example, there's only one that has those 3 missing, those 2 missing, that one, those missing, and so forth. And so that's all I've got for this video. We'll pick up where this one leaves off in the next